Okay, we are back with more proportional relationship things. It's just now we're going to focus on graphing. Remember, this is your graph. A lot of people confuse a graph and a table. Remember, this is what a table looks like. This is what a graph looks like. So, graphs of proportional relationships show a comparison of two quantities, your x and your y, on the graph. Remember, your x is that horizontal axis, and your y is your vertical axis right here. All proportional relationships go through the origin. And remember, the origin is that point 0, 0, right in the middle of your graph. We have an example down here. It says, Ms. Lamphere loves to bake. She decided to make Oreo cheesecake for math department meeting. The graph below represents the eggs needed for her recipe. We see that this is a proportional graph because it goes through the origin. That makes it proportional. The way I would read this graph is I would see that for one cheesecake, I come up here, I see that it's going to cost, or I'm going to use 4 eggs for one cheesecake. And then if I continue up on the graph for 2 cheesecakes, I run the line at 8. So 2 cheesecakes are going to use 8 eggs. Again, I'm throwing stuff. 1 cheesecake is going to use 4 eggs. If this graph was going to keep on going, how many eggs do you think you would need for 3 cheesecakes? 3 cheesecakes. If I just keep extending this line, I would see 3 cheesecakes would need 12 eggs, and I could just keep on going and going and going. That's how you would read a graph. So the first question that we have down here is, what is the constant of proportionality or unit rate when comparing how many eggs are needed per cheesecake? When we're trying to find that constant of proportionality, remember other words that we've used for that are unit rate, and we talked about unit rate last time, and you've also seen that word slope. So when they're asking you for the constant of proportionality or the slope on a graph, do you remember how we did that? There's a few different ways that you can do it, but the way we learned in the year was we would do the rise over the run between our pretty points. We would do the rise over the run between our pretty points. Remember, a pretty point is where the line of your graph is easily read on the x and the y axis. So my origin's a pretty point, right here is a pretty point, here's a pretty point, here's a pretty point. It doesn't matter which pretty points I pick, they just have to be ones that I can read. This is not a pretty point because I don't know exactly what that is down here. This is not a pretty point because I don't know exactly what that is down here. So when we're finding our rise and our run, we go between our dots. Because the numbers on my side are going by ones, each of these jumps is going to represent 1. So my rise would be 1, 2, 3, 4. And my run would be 1. And then I simplify if I can. 4 over 1 is going to simplify to 4. It does not matter which pretty points we pick. We will always get 4 over 1. So here we again go 1, 2, 3, up 4, over 1, up 1, 2, 3, 4, over 1. This 4, that constant of proportionality, that slope, it's the same between every single pretty point. I could even, if I wanted, pick 2 pretty points that are not even close to each other. I could pick this pretty point down here and this last one up here. I would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I could have my rise be 12 and my run be 1, 2, 3. Because what's 12 divided by 3? 4. I'm going to get that same number. I just have to simplify it. So remember, constant of proportionality, unit rate, slope, all those words mean the same thing. Our second question here says, use the graph to represent, using coordinate pairs, how many eggs are needed for 1, 2, and 3 cheesecakes. So my cheesecake, that word is on the bottom of my graph. The bottom of my graph, remember, is the x values. And the numbers on the side, my eggs, those are my y values. When we write using coordinate pairs or coordinates or ordered pairs, all of those words mean the same thing. When I write my coordinate pairs, I have to write it as x number, comma, y number. I have to write it as x, comma, y. So these numbers for my cheesecakes, remember the cheesecake numbers, those are my x's. So 1, 2, and 3, those numbers are going to come first because those are x's. So if I come to my graph, I see that 1 cheesecake is going to be 4 eggs. So the way I would write that is 1, comma, 4. 1 cheesecake for 4 eggs. If I have 2 cheesecakes, again, cheesecakes on the bottom, that's my x. X's come first. 2 cheesecakes would be how many eggs? 8. So that coordinate would be 2, comma, 8. You try for 3 cheesecakes on your own. What would that one be? 3 cheesecakes would be 3, comma, 12. And those are my ordered pairs for my cheesecakes. Question number 3. Sorry, I'm going to try to get all this on the page for you. So question number 3, how is the constant of proportionality and slope related? What do we talk about right here? They're the same thing. Your constant proportionality, your slope, they are the same thing. They are the exact same thing. It doesn't matter which word you use, you're always going to be talking about the same thing. Number 4, they want us to write an equation. Oh, y'all can't see that. Hang on, let me slide up. Number 4 says, write an equation to represent how many eggs are needed per cheesecake. Let x represent the number of cheesecakes, because cheesecakes on our x, and y represent the number of eggs. From our last video, we talked about how equations with proportional relationships, there is no adding or subtracting. There is no adding or subtracting, we're just multiplying and dividing. Remember, proportional relationships are in the form y equals mx. Y equals mx. For this problem, our x, they tell us, is the number of cheesecakes. And y is the number of eggs. What does the m tell us, or what number goes in the m spot? Remember the m, that's your slope, your unit rate, your constant of proportionality. That's what's going to go in our m. Our y and our x, those are going to stay y and x. So our equation is going to be in the form y equals, our m is our slope. What did we say our slope was here? Our unit rate, our slope is 4. So I would plug in 4 for the m, my slope. And again, the x, that's the number of cheesecakes. So our equation for this situation would be y equals 4x. For number 5, they want us to use this equation to figure out how many eggs Miss Lamphere would need to make 4, 6, and 8 cheesecakes. So we want to start off with our equation. Y equals 4x. And we need to substitute in for 4 cheesecakes. Where am I going to plug that number 4 in? I need to plug that number 4 in for my x. Because remember, x, that's your number of cheesecakes, like it tells us on the graph. So I would need to plug in. So I would have y is equal to 4 times 4. What is 4 times 4? 16. So if we make 4 cheesecakes, we need 16 eggs. Now we need to do this again. Start off with your equation. Now we're going to plug in, we're going to substitute for 6 cheesecakes. So again, we get y equals 4. And now we're taking it times 6 because we have 6 cheesecakes we want to make. What's 4 times 6? 24 eggs. We're going to need 24 eggs for 6 cheesecakes. Go ahead and try the 8 cheesecakes all on your own. Again, you should get y equals 4x. You should be plugging in 8 for this x. 4 times 8 is 32 eggs that you would need for 8 cheesecakes. Now what they want you to do with this question 6 is to write ordered pairs to represent the same amount represent the amounts in question 5. So using these numbers up here, your number of cheesecakes and eggs, they want you to write ordered pairs like we did here. So go ahead, try that one on your own, the whole thing. Sorry. Let me get my papers all arranged for you. Using the numbers from question 5, pause the video and write the ordered pairs to represent those amounts in question 6 for me. The coordinates, the ordered pairs, remember they mean the same thing, that you should get are 416, 624, and 832. Remember the x's come first. The x is the number of cheesecakes. The x is the number of cheesecakes. The y is the number of eggs. If you have any questions on this, please send me or Mr. Snook an email. We'd be more than happy to help you and explain things further or give you more examples. Go ahead and get ready to start working on Edmentum with this new unit.